quantum computers are rapidly becoming more relevant in solving the hardest problems humanity is facing.
However, practical quantum computers will need millions of qubits to be in a constant state of tune. But today, with the control methods that we have, we need 3 or 4 quantum scientists to continuously take care of the quantum computer just to keep it alive. This does not scale. Slow tune-ups are already hindering the development of quantum computers beyond a few tens of qubits. But now, we have a solution. We envision a world where every quantum computer will be fully automated, allowing scientists to focus on more important tasks. This will accelerate the path to practical quantum computers. Here we are at the Blue Force Lab at the world-famous TU Delft, one of the great centers of superconducting qubits. Welcome to QuantrolOx. And here we are in front of a Blue Force dilution fridge. In this, we have 2 QPUs from Quantware, which are independently wired up to 2 different control electronics. And here, my colleague Yelena will introduce us to our first product, Quantum Edge, which has been integrated into the control electronics from the Q-Blocks cluster series to automate the running of quantum computers. So Yelena, why is this important and how is this done?
Thanks, Vishal. Today we need 3-4 scientists around quantum computer setups to constantly intervene to make sure that they work, with tens of windows open during the tune-up, making their job really difficult. And as the number of qubits on the QPU increases, the challenge and the complexity of tuning and characterizing them grows significantly. So the current solution that depends on constant human interventions and expertise will not scale. That's why we made Quantum Edge, software that brings automated tuning and optimization of the QPU in one place. It has an intuitive and easy-to-use user interface. Let's take a look.
Hi, I'm Dominic, co-founder and head of quantum technologies here at QuantrolOx. I'm going to show you how easy it is to use Quantum Edge to automate quantum computers. Here in the center of the QPU monitoring screen, we have a graphical representation of our topology. The topology shown represents a 5-qubit soprano made by Quantware. The topology is used to quickly convey information to the user. Using this drop-down menu, we can select metrics to plot on the topology. For example, we can show qubit frequency or single qubit gate fidelity. When automation has been running, this will be updated. Navigating to the automation workflow screen, we are presented with our workflow. A workflow allows us to achieve automation by chaining together many experiments, which we call control segments. This workflow is designed to calibrate single qubit gates. When we start the workflow, we begin progressing through it on all available qubits. We can see the progress of a specific qubit by selecting it in the topology. While automation is running, we might want to look at the data that is generated by it. For this, we can navigate to the data visualization screen. Here we're presented with a navigator for filtering data visualizations. Visualizations are produced by each control segment. All plots are interactive and contain useful context, such as analysis results. Now automation has finished successfully, we can navigate back to the QPU monitoring screen and see the topology has been updated with metrics that were measured. And that was how easy it was to use Quantum Edge to automate quantum computers.
As you can see, we've developed software with one unified user interface that frees up scientists' valuable time and accelerates development cycles. As you saw, smart automation brings us to useful quantum computing faster. At
QuantrolOx, we are committed to building an open architecture quantum ecosystem so that our customers can choose the best components for our quantum future.